In the early days of the digital age, large mainframe computers, often weighing tons upon tons and spanning hundreds of square feet, were looked to as a beacon of technical prowess. Today, everyday consumers carry the processing power of those behemoths in their pocket. This rapid advancement in technology and its eventual ubiquity has also bolstered the advancement of correlated sectors and the democratization of innovation.
Data has always been a challenge for people. We used to accumulate data and store it in our memories. We later started to write data down on pads of paper and keep those in files. But once the electronic revolution took hold, we were able to store and retrieve data very quickly.
You couldn't innovate and do the types of calculations you need on computers unless you had a huge mainframe that took up 2 rooms with all kinds of cooling systems. And obviously now our cell phones or this little watch I have on my wrist does just as much calculating as those big computers did back then. It changed our world because suddenly 5 individuals with 5 laptops could do the same amount of computing and analysis that it took a huge corporation to do before. And that meant people could have startups and invent things and build new technology and take stuff to that next level quickly. And it freed people up. Suddenly anybody could do things.
Artificial intelligence has been going on for well over 40 years. It's the level of computing power that we have today that's made a drastic difference. What AI does for us is it allows us to automate our systems. What used to take many people, I'll give you an example. If you wanted to do surveillance of some area, you would need a dozen people to watch monitors. You would need people to go out and intercept, and you'd need support staff. Today, we can cut out most of the dull and dreary work of watching monitors and leave that all to machines.
You might not think that optics and electro-optics is sexy, but it is. If you think about where our world is going, everything's getting smaller. Years ago, you needed a multi-billion-dollar satellite that only a president could use to see the world. Now, there's going to be hundreds of thousands of small, low-flying satellites that will be available to the average person. You want to study birds, you're going to be able to buy some satellite time and study bird migration for a particular population that you want to protect. You want to look at the polar ice cap, you're going to have all the data because artificial intelligence and machine learning will be able to analyze that data, congregate it between many different satellites, and tell us where the world is going. And it creates a democratization of data we've never had.
It's the advent of artificial intelligence, machine learning, convolutional neural nets. We're heading to an autonomous solution set so that when we put our cameras out in the field, network them, and process all the data, the cameras can do it on their own.
The United States as a nation has been at the forefront of innovation for hundreds of years. So when electronics came, we created the next generation electronics. We built the first fiber optic telecommunications systems, the first lasers, the first receivers. There's just been all kinds of innovation over the years, but there are plenty of areas where we're no longer the leader, but there is an area where we still lead, and that is electro-optics and the networking of things and how we allow things to communicate and tell us more. When I started this company 17 years ago, it was all about building the most complex, long-range, advanced sensor systems, but it's evolved. Several years ago, we began working on more complex problems of once you build the best long-range sensor, how does that communicate to somebody's cell phone in the field? How does that communicate with a drone, with another person? How do all of those sensors network and doing the processing at the edge so we can analyze the data out in the field and then having artificial intelligence learn from that and tell us what's really going on.
In the field that we're in, STEM and STEAM are critically important. This is an area where you get to use geometry. Most people say, where will I ever use geometry? Well, you do in electro-optics. But the beauty of it is, electro-optics requires ideas. We look to people who are innovators. Innovation comes not just from the same people thinking about things the same way. Innovation comes from a broad range of backgrounds.
When I started my career, I could count the number of women I worked with out of 2,000 members of Core Bell Labs on one hand, and I could count any diversity, people of color. I think I was the only Latina there. So it was a very homogenized way of thinking and inventing and innovating. What I have seen is a slow but consistent progression where when you get a diversity of thought and when you put those together, you look at problems differently. You think differently. And that is what is creating true innovation moving forward. As I see the vision of who our company is and where we're moving forward, it is the processing at the edge to truly understand what we're seeing. Is that a person? Is that a cow? Is that a gun? What information do we have on our cameras? But what really makes it powerful is when those sensors can communicate and when intelligence can help us learn and process beyond what the human mind can do.
Clear Align, transformational thinkers solving complex problems. For more information, visit clearalign.com.